Yes. So how many of you are learning IPsec for the first time? If you are learning it for the first time, just type 1 in the chat. First time, first time. Many people are saying first time. Hello, good evening, good evening. Good evening, everybody. The ad session started. Not yet. We'll start session soon. Someone record this training. Thanks. Yeah, we are recording the session. Later you can find the video on YouTube. I want to do the lab on IPsec VPN. So this is my first time. Definitely you will have lab, right? We'll see the configuration of IPsec also. And we have different types of IPsec. So we are going to configure the most popular one, which we are using in the production generally. Commonly used IPsec. Yeah, first time. Hello everyone. First time 111. So many people are saying first time 1 means many of you are learning IPsec for the first time. Definitely I have to go with basic. I have to go with basic. If you are watching me on YouTube, then also let me know in the comment section. If you are learning IPsec for the first time, type yes. Yes, hello. If anyone want to speak, you are allowed to speak. In first 10 minutes, you are allowed to speak if anyone have any question. Once we'll start the session, then I will request you to keep yourself on mute, right? And whenever you will have question, you can raise the hand. I will allow you to speak. Sunny Kumar, yes, first time. What is Diffie-Hellman? Don't worry. We are going to see the Diffie-Hellman and HA protocol, whatever encryption algorithm or hashing algorithm we have. First, try to understand the technology. Soon we'll start the video in class. Yeah, I always watch your YouTube video. Thank you so much for watching me on YouTube. Rinjin, Doji. So many of you are learning IPsec for the first time. Guys, how many of you know the VPN? What is VPN? Let me know in the chat again. If you know what is VPN, then type yes. If you don't know what is VPN, then type no. Because just I want to check, I should start from the VPN or directly I should start from the IPsec. Yes, yes. Secure tunnel. I know VPN. Yes, yes. Many of you are saying yes. Yes, little bit. Secure tunnel. First of all, if I am saying VPN, that means I am talking about which VPN, guys? There are so many VPN. L2 VPN. Am I talking about L3 VPN? I'm talking about Get VPN, IPsec VPN, GRE VPN. Which VPN? Side-to-side VPN. Again, in side-to-side can be GRE also. Side-to-side can be IPsec also. VPN means private tunnel for remote access. Okay. VPN is virtual private network. Is VPN secure? Someone is saying tunnel. What is tunnel? Okay, how many of you know the tunneling? Tunneling protocol. What tunneling protocol does? Provide end-to-end private connection. Overlay, GRE tunnel. GRE is tunneling protocol. What is tunneling protocol? IPsec tunnel. Doesn't matter which tunnel it is. It can be IPsec phase 1 tunnel. It can be IPsec phase 2, like ISACMP or IPsec phase. Encrypt the tunnel. Encryption is the main issue, brother. VPN used to communicate between different sites securely through an untrusted network. Okay. End-to-end virtual connection. End-to-end virtual connection is not the tunneling protocol, right? Okay, few new terms came here in the comment section. I am able to see, like encryption, tunneling, VPN create virtual private virtual address link to process the communication. Okay, one new term is there, that is overlay. Just on my screen I am going to type these new words which are coming here. First one is tunneling. Tunneling protocol. Then someone said overlay. Overlay. Someone said encryption. Someone said side to side. You can share your screen. Screen is not visible. Let me share my screen. Yeah, let me know, is my screen visible now? Whoever are watching me on YouTube, please confirm am I audible and my screen is visible clearly. I am able to see your comment here. Just type yes if everything is clear. If my screen is clear and voice is clear, type yes. Hare Ram Singh, please confirm. If I will arrange this topic now, so first of all you should have idea about overlay. Then you should have idea about VPN. Yes, many people are saying yes. Thank you, Akshay. Thanks for the confirmation. Yes. Use of DH group. Yeah, DH group. Diffie-Hellman group. We'll talk about that. Volume is low. Is my volume low there? Hello. I think it's fine. Let me check. Here, guys?
Yeah,
It's
here.
fine? Clear? Okay. Great. Volume is good. So first term is overlay. Guys, just I want to know first overlay. What is overlay? Overlay, it is physical network or virtual network? It is physical network or virtual network?
Virtual network.
It is virtual network. And where we are creating overlay? Virtual network on the top of underlay or physical network. Physical network. That is called overlay. Any technology, any overlay technology creates virtual network on top of the underlay, physical network. Underlay means physical network, overlay means virtual network. For an example, let's suppose you all have configured the BGP. So let's say here I have router 1, router 2 and router 3. Three routers are there. On router number 1 I have one loopback 1.1.1, and on router number 3 also I have one loopback 3.3.3. Can I configure BGP neighborship between 1.1.1 and 3.3.3 directly? Here I have one loopback 1.1.1.1. Here I have one loopback 3.3.3. Question is, can I create BGP neighborship, BGP session between 1.1.1 or 3.3 or not? 1.1 and 3.3.3. Can I have that BGP session without involving
Yes, sir.
I2? Yes. And that network is going to be overlay or underlay?
Overlay.
BGP is going to be
Overlay.
overlay, right? And this physical network which you are able to see, the router 1 is connected to router 2 and router 2 is connected to both the router, is your physical underlay network, right? Maybe here IP address is 12.1, here IP address is 12.2, here IP address is 23.1, 23.1 or 2, let's say 23.2. So this is my underlay network. But what is the requirement to create any overlay network between router 1 and router 3, underlay connectivity. Right? You can only create this BGP session between 1.1.1 and 3.3 if your underlay reachability is there. If the physical networks are working fine. If there is reachability issue, let's say R2 is not working fine or their interface is not working fine, automatically my overlay will goes down. So even we have created the virtual network, but virtual network is rely on your physical network only, right? Even when I am going to send any traffic through BGP, router will forward traffic through this physical network only, through this physical cable only, right? This virtual is what? Just a virtual link, but we cannot forward anything through the virtual link. This is the meaning of overlay. Overlay means a virtual network on top of the physical network. Then second term was VPN. Second term was VPN. What is VPN, guys? What is VPN? Virtual. VPN stands for
Virtual private network.
virtual. It means virtual means overlay, and after that private network. Means VPN is also known as by private WAN. We can call private WAN. See, to understand VPN, first if I am going to talk about IPsec, let's say. So see, IPsec VPN is the complete name. Means there are two terms, IPsec plus VPN. So to understand IPsec, first of all you have to understand VPN. To understand VPN, first you have to understand overlay. How overlay is going to work on top of the underlay. And then you will see the VPN is not providing the encryption, means there is no security. Right? So to secure the virtual private network, we are going to use what? IPsec. To secure the virtual private network. Now if I will talk about the VPN, VPN is nothing but the tunneling technology. Tunneling technology, you know, like Cisco introduced in 1990 this protocol, tunneling protocol. Right? Cisco come up with their first tunneling protocol called GRE. GRE. Tunneling is nothing but one concept, one mechanism to encapsulate any traffic into layer 3 traffic, into the IP traffic. Encapsulating means adding the extra information, right? The meaning of encapsulation is adding extra information. So Cisco come up with first tunneling protocol called GRE around I think 1990. So VPN is nothing but the tunneling technology. Tunneling technology, or I can say virtual network running on top of the physical network. It is overlay. You know, before VPN, guys, if I will talk about before VPN, how many of you know before VPN how I were connecting multiple sites together? See, if I am talking about VPN, that means I am talking about WAN, wide area network. Am I right? I am talking about wide area network, means connecting multiple sites together. Overlay, provide end-to-end. Okay, frame relay. Okay, very good. Someone is saying frame relay. May I know any other solution before VPN? Encryption means securing the network using algorithm like AES, DS, etc. Yes, very good. Leased line. Before VPN, we were using these technologies like frame relay, ATM, leased line, MPLS. So how VPN replace these all WAN technologies? What is so good in VPN? Earlier, organizations connects their multiple site by using, lease line was so famous. Let's say this is my DC and I have 2 branches. Right? So earlier we were using lease line here between all the sites. Lease line is private connection between 2 points. But the issue with lease line was encryption. Issue in leased line was what? Encryption. Even this is private connection, this is secure. Leased line is secure, it is private connection, but your data will travel in plain text. Right? The first issue was cost. Leased line was very expensive. Second issue was what? Note encryption. If I will talk about any VPN, like maybe you can say GRE VPN, which is used to connect 2 sites through internet, through public network. Or if I will talk about L2 VPN, MPLS L2 VPN. Right? Or I will talk about MPLS L3 VPN. All are connecting multiple sites, right? Or any private WAN connection, any private WAN. These all the technologies, first of all, first thing that you need to keep in mind is VPN doesn't mean encryption. VPN does not mean encryption. Right? Your service provider between 2 sites, let's say here is my service provider and I am connecting 2 sites together through this service provider. Site 1, site 2. This service provider can be MPLS, any service provider, Metro, Ethernet, 4G, 5G, lease line, any service provider. So these service providers are creating VPN for what? To keep your data separate from different customer, because like you, multiple customers are connected to this service provider network. So they are just responsible for separating your traffic, right? They will make sure that your traffic, your data is not going to get mixed with other customer, and at the same time they are just providing connectivity between 2 sites, right? These all technologies does not supports encryption. GRE, MPLS L2 VPN, MPLS L3 VPN, Get VPN is secure, by the way. We'll talk about the Get VPN also. Then here what we can have, any types of VPN or any type of WAN connectivity, private WAN, like your lease line, frame relay. These are not secure. Your data will travel in plain text only, right? So as I told you earlier, company were using leased line mostly to connect their multiple sites, but issue was expense. It was very expensive, and the another issue was encryption, not encryption. Data were traveling in plain text, but the leased line was point to point connection, a dedicated physical circuit between 2 sites provided by the telecom provider. Who were providing leased line? Telecom providers, and they were using technologies like T1, E1, T3, E3, OC3, right? SDH circuit. These are the old technologies used in leased line for connecting 2 private sites together. This is private, secure, but very expensive, but data is traveling in the plain text. If service provider is going to read my data, I cannot do anything, right? They can capture it. So because of high cost and limited scalability, there was a scalability issue as well with leased line. Scalability means what, guys? What is the meaning of scalability? Yeah, tell me in the comment. Here tunnel is secure, but data is not secure. No, even your tunnel is not secure. The GRE tunnel is not secure. No scalable. Expand. Yes, according to our requirement, we can increase or decrease the size of network. That is scalability. But lease line is not available everywhere. You cannot find it very easily, right? And even the setup deployment is going to be complicated, as it is physical dedicated link between two sites. Even costly, not secure in terms of authentication and security. Like here in leased line, we cannot verify that traffic is coming from the genuine user only, the source is trusted only, right? Like that type of authentication is not possible. But if you need guaranteed bandwidth, if that is only your priority, then you can go with leased line, no problem at all. Am I right? After that, after leased line, we come up with MPLS also, right? So if MPLS is so good, then why we need IPsec? I'm not saying MPLS is so good. Even IPsec is going to replace the MPLS as well. Many companies are using IPsec because IPsec VPN is secure as well as cheaper as compared to these all WAN services, WAN technologies. So when we come up with MPLS, what was the main, benefit, the advantage of MPLS? What is the main advantage of MPLS? Forwarding process, right? MPLS is, yes, fast, definitely. If I will compare MPLS with leased line, then MPLS is going to be fast because it is using different method for data forwarding, that is switching method. IPsec VPN is most secure and cheaper, yes, definitely. So MPLS is multi-protocol label switching. It is also a private WAN technology where service provider create virtual private network VPN using label switching routers. By using label switching router LSR, service provider is going to create VPN virtual private network over the MPLS circuit by using label switching router. And the technology under MPLS is, MPLS L3 VPN, MPLS L2 VPN, right? Like L3 VPN, L2 VPN, then we have what? VPLS VPN, then we have eVPN, right? So these are the technologies used in MPLS. Service provider uses this technology to provide you connectivity between sites, multiple sites. It is, I can say that MPLS is more secure than, can I say MPLS is more secure than leased line? No, because both are private connection, but I can say MPLS is more secure than internet because we know internet is not secure, like your GRE is not secure. So when MPLS comes, banks or multinational companies, started connecting their multiple sites by using MPLS. Sometimes we were preferring L2, sometimes L3 VPN. For the security, we were using eVPN, Get VPN for L3 VPN security. Like to secure L3 VPN, MPLS L3 VPN, you can use Get VPN. For the encryption, as I told you, L3 VPN is not providing the encryption, not provide encryption. So if you want to encrypt the data, user data end-to-end encryption, you can use again Get VPN like IPsec VPN. I am going to use IPsec for our GRE, right? And what can be the limitation of MPLS? Again, expensive. And even when you are going to purchase the MPLS from the service provider, required a coordination with ISP, right? And the main issue is no inbuilt encryption. So even it is best for the large organizations or medium-sized organizations who need the stable connectivity between multiple sites. Right. After that, we had one technology called frame relay as well. This is also very old technology, frame relay. Nowadays, we are saying legacy WAN, and the frame relay is replaced by your MPLS only. Replaced by MPLS only. Right. Actually, you know what was happening in the frame relay? A packet switched network where multiple sites share a virtual circuit, right? It was working on virtual circuit. Multiple sites were using virtual circuit. Right? But this is old one, and we are not using it nowadays. Even MPLS have replaced it, right? Because the MPLS was so faster than frame relay. If I will compare frame relay and MPLS, then MPLS is much faster than frame relay. So that's why MPLS replaced frame relay. And which technology the frame relay was using? PVC, permanent virtual circuit only, right? And good thing is you don't need to learn it, right? Another technology over there that is called, I think, DLCI, data link connection identifier, right? And frame relay was also private WAN, but data was not encrypted. You can see in all the technology we have issue of encryption only. The major issue is encryption and cost. The major issue in all types of technology is encryption and cost. All are costly and not encrypting the data. Correct? MPLS is fast. Yes, very good. Encryption issue is there. So we were using MPLS until we were using frame relay until MPLS become popular. Once we come up with MPLS, we started using MPLS. Before MPLS, we were using frame relay as well. So frame relay is also not going to work. Then ATM technology over there, right? We'll not talk about the APN because it is nowadays you will not find anywhere, right? The ATM setup was very complex. In the book only you will find these concepts. Then dial-up was also there. Dial-up and ISDN, right? So these all are filled. Nowadays we are not using it. This is for phones, right? After that, we also come up with satellite link. So we can connect two sites through satellite also, and this is still in use, right? Still in use in remote areas where we cannot place the cable. There we are using satellite link only. Through satellite link also we can connect multiple sites. It is still in use in remote areas. It is also used to connect remote locations where fiber or leased line is not available, right? And it is using which technology? VSAT, very small aperture terminal. But again, satellite is not providing encryption. Again, same issue I have, the encryption. Data is traveling in plain text only everywhere. Right? So that's why, guys, see, in all these types of VPN, we are like our data is in plain text. So that's why we come up with IPsec. IPsec, and like IPsec, we have so many VPN for the encryption who provide security. Can anyone tell me IPsec offer how many services? And what is IPsec in single line? IPsec offers which type of services, how many services, and what can be the definition of IPsec?
IPsec provides confidentiality, integrity, authentication.
Authentication, integrity, and confidentiality. What is
Yes.
confidentiality? Encryption the data over internet, secure connection. IPsec is suite of protocol. Yes, suite means group of protocol. Like your OSI model. OSI model is a group of protocol. Someone is saying CI. Okay, if we need encryption, if we need guys encryption, authentication, okay, fine, got it. If I need to encrypt data between two sites, for an example, this is my scenario only. Let me copy it. And see here I have two sites, both are connected through internet. Both are connected through internet. Both the sites are connected through internet. This is my topology. Two sites are there, both the sites are connected through internet, ISP. Are you able to see this lab, this topology? You can see my LAN network, LAN subnet 192.168.1.0 connected to router number 1, 192.168.2.0 is connected to router number 2. This side it's 2.0. And on both router I am using public IP address on the interface facing towards internet. Right? So tell me, can these two private sites communicate by default through internet? No. No. You know,
No.
private and public IP can never communicate, cannot communicate by default. And the technology which we are using to make it possible, like communication between private and public, is called NAT, network address translation. Similarly, two private sites can not communicate over public network. Two private sites cannot communicate over public network. Public network means like your internet. And the technology which we are using to make it possible is nothing but the VPN, or you can say GRE VPN for now. I am saying GRE VPN. So GRE VPN is going to make communication possible between these two sites, but again will not provide encryption. It is going to send data in plain text. Right? See, internet connection is guys very cheaper than MPLS or your leased line. If somehow here we can configure the secure tunnel between router 1 and router 2, because internet is even not secure. Even MPLS or leased line was private connection. This is public subnet, right? Good people and bad people, both types of people are there. You cannot send your data directly, the company data. So if we can send the data through internet between two sites securely, then it is going to be cheaper also, and it provide security as well, the encryption as well. So the first thing is about, let's say, GRE only. It is cost effective. Even it is not providing security, then also at least we are able to connect two sites together like the MPLS. And see, it's very easy to deploy, right? Scalable, it's more scalable than MPLS. To purchase internet connectivity, anywhere you can purchase the internet connectivity very quickly. Even for the MPLS, you need some time, sometime 1 week, 1 month, 2 months. At some location, maybe more than 6 months also. It is not so scalable. But if I will talk about the internet is, guys, so scalable, available everywhere. But issue is, if I am going to use here GRE VPN, then security. My data is going to travel in plain text. Anyone on the internet can change the data, can read the data, can know the company credential data. These are the issues. But GRE VPN is at least cost effective, very cost effective. No need for expensive leased line or MPLS circuit to connect two sites. If I have something to secure it, then only I can use it, GRE. Another benefit can be, you can see, easy to deploy and expand your network. And the another thing is, at the same time, see, if I have two sites, and if I am going to connect these two sites, guys, through, let's say, MPLS. This is my branch 1 for an example, or headquarter, and this is branch 1. If I am going to connect these two sites through, let's say, MPLS circuit, can I have internet access? Can I have internet access here? No. MPLS is just providing what? Connectivity. Your two sites are now able to communicate. If you need internet, here you have to connect internet separately, like this, maybe in HQ or in both sides. But if I will talk about the GRE here, this scenario, we are getting both. We are getting VPN like L3, L2, MPLS L3, L2, as well as internet access, right? In this scenario, I can have internet access as well as VPN, right? So it is not only VPN, it is internet plus VPN. Internet plus VPNs. Getting my point? Yes. Thank you. Internet plus VPN. These two sides can communicate securely. If I will talk about, current trend, like in the current scenario, which options we are using? If you are going to ask me, Praful, nowadays, tell me, if we have so many WAN solution, if we have so many technologies, which are nowadays we are using, So in the current trend, mostly we are using VPN plus SD-WAN. MPLS, even MPLS is not required nowadays. With the SD-WAN, we don't need MPLS also. We can have multiple internet connection. That is also fine. But we have only one issue, that is security. Because right now we are able to see the GRE, but GRE is not providing encryption. It is not secure protocol. Yeah, someone has raised the hand. Please speak. If anyone want to speak, you can speak.
Can you hear me?
Yeah. You are audible.
Okay, I wanted to, if I get you right, for GRE VPN, we can get internet plus VPN, that plus connectivity.
Yes. Means your two sides can
That
also
is-
communicate, and these two sides can access internet as well at the same time.
No, Does that mean I have my HQ and I have my branch? I have internet at my branch, and I want my branch to get internet from the HQ. Is that possible?
Yeah, that is possible, bro. Why not? You can route the traffic anywhere, right? That is routing
Okay.
only,
Okay. Okay. Thank you.
right? Like if I can tell to configure this scenario in such a way so that whenever someone from here want to access internet, this internet, first of all through the VPN, here we have VPN. So first of all through the VPN they should reach to R1, and then R1 is going to inspect the traffic, and maybe after that it will allow to go to internet, and in this way only reply will come. So first through your VPN you are routing the traffic to R1 to side 1, and after that from side 1 you are sending traffic towards internet. That is possible.
Okay.
But what I told you, nowadays many companies uses SD-WAN plus IPsec VPN instead of MPLS, because this is the best. If somehow we can secure this GRE, then this is going to be best. But issue, there is one issue. See, we have IPsec VPN. Soon I am going to tell you about multiple VPN, or GRE over IPsec also. Like we have GRE tunnel, and we can secure that GRE tunnel through IPsec. Then we will call that GRE over IPsec VPN, right? And why this one is most popular? Because you know the IPsec VPN is not created for routing protocols. If you have created the IPsec between router 1 and router 2, let's say, and if you want to run any routing protocol like OSPF, EIGRP to exchange your routes 192.168.1.0 and 2.0, you cannot do that. If you need routing as well as security, then you have to use GRE over IPsec only, and this is the reason why GRE over IPsec is so popular. And guys, whatever technology we have seen here, see, all are similar technologies, all are private WAN only, but the key difference is what? Key differences are in terms of cost, security, scalability, and how they handle the traffic. These are the differences between all these technologies. The purpose is same. Purpose of all the WAN technology is same, connecting multiple sites. And some of these older technologies are still in use, like you can find leased line somewhere, you can find MPLS, right? Even leased line is more expensive than MPLS. So that's why mostly you will see the MPLS. Mostly we are using MPLS, but we are not using frame relay, we are not using ATM, we are not using dial-up, ISDN, and we are still using satellite. So these are still in use nowadays, right? If I am going to say VPN only, right, only I am saying VPN, that means it can be any VPN. It can be GRE VPN, it can be IPsec VPN, it can be SSL VPN, it can be Get VPN, any VPN, right? So either you should say IPsec VPN or GRE over IPsec VPN to connect two sites. Is IPsec point-to-point VPN, guys? Who will answer to this question? Answer me in yes or no. Is IPsec point-to-point VPN? Yes or no? If you are saying yes, type yes in the chat. If you are saying no, then type no in the chat. Is IPsec point-to-point VPN? So whoever is saying yes are wrong. IPsec can be point-to-point also, and it can be multi-point to point also, like we can implement IPsec in DMVPN also, dynamic multi-point virtual area network. Right? And these VPNs, the IPsec, SSL, GRE over IPsec or DMVPN, these are secure technology. These are providing encryption. And you need to learn that in the IPsec. How? How? Encryption. Now, who will explain the encryption? What is encryption?
It is plain text to cipher text, right?
It is plain text to cipher.
Cipher text.
Very good. Very good. Very good. So let's say I have two sites, side 1, side 2. Both are connected through internet. And if I am going to encrypt the data by creating one algorithm, by let's say myself only, this is internet, I am trying to secure the GRE. R1, R2 and INET, internet. Right? So here I can encrypt A into 1, B into 2, C into 3, D into 4, E equals 5, F equals 6, like this. This can be one encryption algorithm. This is what? This is my simple key. This is simple key that I am using for encryption. And same key maybe router 2 is also using for encryption and decryption. And now here is one user, let's say 192.168.1.1, 192.168.1.1, who is going to send some data to 192.168.2.1. Here I have created some simple key to encrypt the data. Is it secure now? Now between two sites can I send the data securely? Because both the routers are going to perform now encryption by using this simple key. Is it secure?
No, sir. Attacker will also know the key now.
Yes, exactly. See, like if my data is, a user is generating a data is for an example what? Dead. So router 1 is going to send it like how? Router 1 is going to perform encryption here. It will encrypt D into 4, E into 5, A1 and again D4. And when router 2 will receive it, router 2 can again use this simple key to decrypt it, and again router 2 will decrypt it into dead. But see, if I am going to send lots of data from side 1 to side 2, anyone on the internet can guess this simple key. Right? By collecting lots of data, he will see, the attacker is going to see, okay, every time, see, with the help of so many mathematical calculation, combination, they can create this simple key, your algorithm, like you are using 4, whenever you need to send C, you are using 3. By collecting lots of data, attacker can create this simple key algorithm. Because issue is what? Routers are sending lots of data with the help of same key. Whenever router need to send A, it will always send what? 1. So as it is using same key for lots of data, anyone on the internet can guess it. Am I right? Right? This type of attack is called what?
Man in the middle.
Man in the middle, you can say, yes. So if I am going to assign one engineer here on router number 1, hey bro, just do one thing, after half an hour, every time reset this key. Reset this key on both the router. That is fine then. Now no one can guess my algorithm. Like after 1 hour, I am going to use A equals @ Again after 1 hour I will use different key. But is it possible, guys? Is it possible to manually reset this simple key again and again? Not possible. So we need a dynamic method, right? So that router should automatically generate the new key and share with each other. And then we come up with what is Diffie-Hellman? Diffie-Hellman is nothing but just responsible to generate the key and exchange the key between two sides. Right? It will do same task. It is going to perform same task, but dynamically. Right? We can say it is a mechanism to dynamically generate and exchange key between two sides. 1 minute, guys. Right? We need a mechanism to generate and exchange the key dynamically, because if I'm using this simple key, then lots of data can compromise the key. Right? So in the IPsec, first algorithm or protocol which you are going to use is Diffie-Hellman. While configuring Diffie-Hellman, it is going to ask you the key size. It is going to ask you key size. What key size you want to configure. And even it is going to ask you lifetime. Lifetime means after how long you want to reset the key, you want to regenerate the key. After how long? If I am going to say lifetime 1000 seconds, means after every 1000 seconds, Diffie-Hellman is going to create one new key. That key is called session key. And if I will talk about the key size can be your, like, multiple sizes are there. 768 bits. Then we can have 1024 bits key. You can have 1536 bits key. And which are more secure? This is more secure, this is medium secure, this is low secure, right? So if my key length is large, definitely it will use more process. The performance can be slow, but it is going to be more secure. This is in terms of security only. Right. So for an example here, between side 1 and side 2, between R1 and R2, I have configured here subnet is 192.168.1.0/24, and here my subnet is 192.168.2.0/24. Right. Let's say here Diffie-Hellman have generated one key, let's say session key 1, and on router number 2 they have generated session key 2. Right. Diffie-Hellman has generated key on both the router. Right. To encrypt the data, router 1 will use which key now? Earlier it was using your simple key. Now it will use this key to encrypt the data. Session key 1. It is going to use this key to encrypt the data. Router 2 will use which key to decrypt the data? Session key 2. Can router 1 decrypt the data of router 2, side 2? No. Because there is one issue, still there is one issue. What is that? See, let's say user is generating data, any data, and by using their session key, router 1 session key is SK1, session key 1. By using session key 1, it have encrypted the data and then send it through internet to the router number 2. Can router number 2 decrypt it? No. Because to decrypt it, it have to use same key, and router 2 don't know what key router 1 have used to encrypt the data. Am I right? Is router 1 knows what key router 2 have used to encrypt the data, or router 2 knows what key router 1 have used to decrypt the data, encrypt the data? No. That is unknown for both the routers. Right? So now we need to share this key, exchange this key between router 1 and router 2. Router 1 need to send their session key to router number 2. That whenever I will send you data, I will use this key to encrypt. You will use this key to decrypt. And router 2 will share their session key to router number 1. That I am going to use this session key to encrypt the data. You will always use this key to decrypt the data, my data. Right? So if router 2 will have session key of router 1, then it will use that key to decrypt the data, all our data received by router 1, side 1. But can I exchange this key through this public network? No. Right? If you are going to find the key, again you can decrypt my data. Am I right? Yes. So we can note decrypt, like exchange the key directly. So what will happen in the IPsec? See, what will happen here? IPsec is going to create a secure channel between router 1 and router 2 by using again tunneling protocol. By using tunneling protocol, it is going to create one secure channel. What is the purpose of this secure channel? To exchange the key. Right? Secure channel, or you can say secure tunnel. To exchange the key. Which key? Session key. Who have generated a session key? Diffie-Hellman. And guys, you know, to create any secure channel, IPsec or any secure channel, you need three things. First thing is key. Second thing is encryption. And third thing is hashing. Hashing is similar like checksum. You know what is checksum? Checksum means, let's say two PCs are there. Two PC1 and PC2. PC1 is going to send one data to PC2, let's say 10.1, 10.2. Data is, for an example, hello. Right? So hashing is used to make sure that data is not modified. So what will do these PCs are going to use one algorithm. Algorithm is similar like the juicer. Many times I have given you this example. It is going to put the data, hello data, into this algorithm, and it will find one hash value. And it will add that hash value in the Ethernet header at layer 2. Data is hello, then we can have layer 4 header, layer 3 header, layer 2 header, and in the header I can add the checksum value, right? Let's say in the Ethernet header I have added the hash value, checksum value. Checksum value is, let's say, XYZ, and then I will forward it to router 2. Router 2 is also using same algorithm like PC2. PC2 have also same algorithm. If PC2 is using different algorithm, again it will calculate different hash value, and if the hash value will not match, it will discard the traffic. So what router PC2 will do, it is going to also put your actual data into the algorithm, and it will find the hash value. And after that, if the hash value is same XYZ, that means data is not modified, because we put it same data in the same algorithm. So hash value should be same. Encryption means converting plain text of data into ciphertext, which you have seen. And key means the key, authentication. It is used for authentication. So between router 1 and router 2, I need one secure channel to share this, to exchange this session key. For that, here on router number 1 and router number 2, I have to define 3 things: key, and the key configuration can be, again guys, manual or automatic. Like one automatic you have seen, that is Diffie-Hellman is going to generate dynamic key after a specific interval of time. And whenever you are configuring key manually, that is called pre-shared key. Pre-shared key. So through pre-shared key, both the routers are going to authenticate each other. Let's say here I have set pre-shared key Cisco, and here also I set pre-shared key Cisco. So now both the routers are going to authenticate each other, that I am going to establish secure channel with right device or not. If there is attacker on the internet, and if they will try to establish the secure channel with your router, they cannot establish, because first it is going to authenticate. There will be mutual authentication, either by using pre-shared key or by using certificate. Also it can authenticate each other. Authentication, the first step. With the help of pre-shared key, we can authenticate router 1 and router 2. Both are going to authenticate. Once authentication will done, they are going to negotiate the encryption and hashing. The encryption algorithm and hashing algorithm is same or not. And after that, you will have secure channel between router 1 and router 2. If everything is going to be negotiated, both will form one secure channel. And this secure channel is, guys, see, the purpose of this secure channel is nothing but the exchange of session key. Exchange of session key, not to encrypt the actual data, user data. Right? The state of this tunnel is going to be idle. Every time it is going to be idle, right? The work of this tunnel is after 1 hour, right? The by default timer, like lifetime of the Diffie-Hellman is 1 hour. For an example. So after every 1 hour, what will happen? This secure channel will come up, generate the key, exchange the key, and then go to sleep. Again it will be in idle state for next 1 hour. Again after 1 hour, it will wake up, it will generate the session key, it will exchange the session key. So now my routers are changing the key, are not using same key for lots of data. First thing. Right? So at the end, after this secure channel, router 1 will send their session key to router number 2, that my session key is SK1, and router 2 will there on session key, that is SK2. And with the help of guys these keys, now routers are going to create one another secure tunnel for data plane, for data to encrypt the data. This is called phase 1, which is used to exchange the key. We have created this secure tunnel to exchange the key. And then the second step, once both are going to exchange the key, by using that key, even you will not configure the key for the phase 2, it is going to establish phase 2, IPsec phase 2 for the data plane, right, for the data exchange. So if I will give you just one overview here, between router 1 and router 2, I will have two secure channel. Purpose of this secure channel is key exchange, and the protocol which we are using here is nothing but the ISACAMP, right, just responsible for exchanging the key, and after that it will be in idle state. And this tunnel is for data encryption. Data exchange, or you can say data exchange, let's say data exchange, by using which protocol? ESP, right? Two protocols are there, EHP, or you can use EH, right? This is called phase 1. This particular thing is called phase 1, and this particular thing is called phase 2. So we have two phase in IPsec, phase 1 and phase 2. We have established phase 1 to exchange the key, which key? Session key, and phase 2 to encrypt the data. And for both types of tunnel you have to configure key encryption and hashing, right? To create, always keep in mind this point, to create any secure channel we need these three parameters: encryption, hashing, and key. Encryption, hashing, key. Getting my point? What is session key? Okay, someone is asking what is session key. The session key is the key which Diffie-Hellman have generated for data encryption. Not data encryption, for key encryption. The key which you have defined, the pre-share key Cisco, that is going to be encrypted with the help of session key. And in phase 2, it will use this session key to encrypt the data. For an example, after 1 hour, Diffie-Hellman have generated one key here, Cisco, and here CCNP, for an example, right? So through this phase 1 it is going to share the key. So router 1 will receive CCNP key and router 2 will receive Cisco key, right? Now for the actual data, when user is going to forward actual data, it will use this key to encrypt. which key? Their own session key, Cisco, to encrypt the data. And router 2 is going to use Cisco to decrypt that data. And router 2 will use CCNP key to encrypt their data. Right? Through this tunnel it is going to communicate. So all the data is going to be, guys, encrypted. And through IPsec, if I can achieve security, then why I will use any other WAN? Then internet is the best. In the every company you will find internet as a transport. One issue is there with internet, that is internet is sometimes not reliable, but nowadays even internet is reliable. Right? So that's why IPsec VPN is now widely used, because it is more secure, more scalable, and cost effective. It is providing now security. Right? If I will talk about, guys, VPN. So we have so many VPN like IPsec. Then I told you SSL VPN. Then I told you GRE VPN. Then we can have IPsec over GRE. We can have DMVPN. We can have Get VPN. And who will tell me which VPN is not secure here? Which VPN is not secure? Only one VPN is there who is not providing encryption. That is GRE. Right? So actually IPsec, we are using IPsec for side to side, for here we can add the remote access and those VPNs as well. By the way, leave it. Phase 1 uses asymmetric or symmetric encryption. Phase 1 is using, bro, symmetric and asymmetric means what? Symmetric means same key or different key? Same key.
Same key.
So for the phase 1, it is how phase 1 is establishing the secure channel, guys, with the help of pre-shared key. With the help of pre-shared key, that is Cisco, that is symmetric. But if I will talk about phase 2, so in phase 2 you can see for the encryption router 1 is using different key, for the decryption it is using different key, the key of R2.
Sir, I have a doubt.
Yeah,
If
go
one
ahead.
router using one key and another router will using another key, like in asymmetric key, then how they will identify, sir, actual data?
How they will identify?
Actual
See,
data, like if router 1 using one key,
router
in
2
asymmetric.
have IPsec with router number 1, and router 2 also have the session key of router 1, that is Cisco. So whatever traffic it will receive from router number 1, it is going to use this key to decrypt that. And it will be changing dynamically after a specific interval of time.
Okay.
Right? Routers are using different key to encrypt, different key to decrypt. It is using their never session key to decrypt the data. To encrypt, it is using their own key. So where I was? Yeah. So here GRE VPN is not secure, and guys, IPsec VPN is generally used in which case? In case of side-to-side VPN and remote access VPN. What is remote access VPN? Anyone?
Yeah, sir, it's we can access the corporate network from
Yes,
outside,
you
right?
can network your office network from anywhere.
Okay.
Right, so in that case and side-to-side VPN, we will be using IPsec. remote access. You can configure both types of VPN on Cisco devices. If I will talk about the SSL VPN, so SSL VPN is generally used for remote users. Remote users, or you can say like the browser based application. Whenever you need browser based access, that time you will be using SSL VPN. If I will talk about the GRE, so even we are not going to use GRE. We can use GRE if security is not your concern, right? If you need only connectivity between two sites, you can use GRE. Like if you want to run the routing protocol, OSPF, EIGRP, you can use GRE. Because on the IPsec VPN here, you cannot run any routing protocol. In IPsec, you cannot configure routing protocol. So for the routing protocol, we have here GRE. If anyone want to configure routing protocol. Routing protocols like EIGRP or OSPF, etc. Right, but it is not secure. IPsec over GRE, the commonly used VPN, most commonly used VPN, right, for site to site as well as security, like for routing protocol, right? Dynamic routing, or you can forward the multicast traffic, right? IPsec VPN does not support multicasting. IPsec does not support multicasting. DMVPN to connect multiple branch in case of multi-point VPN, if we have hub and spoke scenarios, then we can have DMVPN. And guys, the last VPN, get VPN, is used to it is used for encryption only. Encryption in the MPLS network, MPLS circuit, I can say circuit. Like you can secure your L3 VPN, secure L3 VPN through get VPN. Can I encrypt L2 VPN through get VPN? Can I encrypt L2 VPN through get VPN? No. Get VPN works at layer 3. So you cannot encrypt L2 VPN. You can encrypt L3, MPLS L3 VPN, or any private WAN. You can encrypt any private WAN through get VPN also. So most enterprises uses IPsec VPN, but if you want to run dynamic routing protocol, if you need dynamic routing protocol, then you will use what? Which VPN? IPsec over GRE, right? IPsec over GRE allow you to run routing protocol securely. It support multicasting as well. And when to use GRE? GRE, generic routing encapsulation. Even you know GRE is not a VPN itself. We cannot say GRE is VPN. This is tunneling protocol. GRE is tunneling protocol. GRE does not provide encryption. Even we cannot call it VPN. We are saying GRE VPN, right? But GRE is not a VPN itself. It is tunneling protocol. If you need to run routing protocol like OSPF, EIGRP, multicasting, then GRE is required. But because IPsec alone does not support routing protocol or multicasting. IPsec need GRE. In that case, in IPsec over GRE, IPsec over GRE, GRE is doing what? Here, what is the role of GRE, guys? Role of GRE is?
Creating tunnel.
Yes, creating virtual private network tunnel and running routing protocol. Routing protocols by encapsulating and IPsec is doing what?
Encrypt the data.
IPsec is providing security. Providing security. Right, so this combination is used in Cisco, Juniper, Fortinet, Palo Alto, etc. IPsec over GRE. Right, mostly you will find in the Cisco, in the Juniper, in Fortinet, Palo Alto, right, the advanced devices. That means nowadays SD-WAN and IPsec replaced all the traditional WAN. Right? How GRE is sending the traffic, guys, through the tunnel? GRE means, you know, GRE means sending non-IP traffic over the IP network. That was the main purpose of GRE. Right? It encapsulates different protocols like IPv4 protocol, IPv6 protocol, multicasting, OSPF, EIGRP, etc. over the IP network. And IPsec was developed to provide the encryption, authentication and integrity for the IP traffic. Both IPsec and GRE works at which layer? At layer 3 only. Both works at layer 3 only. IPsec is protecting IP based communication and GRE is encapsulating the traffic over the IP network. Right? So your IPsec VPN works at layer 3. SSL VPN works at which layer? SSL
Sir,
works at layer
5.
4.
Four.
GRE works at which layer? Layer 3.
L3.
Right? Have you heard about L2TP VPN?
No, sir.
Layer 2 tunneling protocol?
No.
It works at layer 2. Right? MPLS also. Sometimes we are saying MPLS works at 2.5.
2.5, yeah, right.
Clear, guys? Any question till here?
Sir, I have a question.
Hmm.
So as you told, asymmetric key will working with Cisco devices, right? Cisco router.
Why?
Only. Because they dynamically, defaultly, they sending the data like asymmetrically. Like I'm not sending symmetrically, asymmetrically.
So on other devices also it can send, na? Dynamically.
Okay. That I am asking.
Yeah.
Other vendors are can do, na?
Open external, yes. All the vendor
Okay.
devices can do. right? Then I can ask you one question, like we have seen that we can use get VPN for an example to secure L3 VPN. How you can secure L2 VPN, MPLS L2 VPN? If I am going to arrange the webinar weekly, I have to arrange the webinar, guys, for these WAN technologies, right?
Okay.
Because it's operate at layer 2. This is the issue. Here I cannot use IPsec or get VPN. So here you will be using what? VPLS. VPLS. VPLS, or you can use EVPN. You might have heard about EVPN to secure it. You should use like MAC security, layer 2 encryption. So company uses VPLS for layer 2 security and IPsec for layer 3 security. Now if I am going to ask you what is IPsec? Now if I will ask you what is IPsec, what will be your answer?
So it is a group of protocol, right?
Yeah, okay, group of protocol. Good.
To transfer the data over the
Open
network
standard protocol
securely.
that provide secure encrypted
IPsec
communication.
stands for what? Internet
Internet
protocol
Negative protocol
security.
security.
Right. Protocol security. Okay, right.
Okay. Internet protocol security. It is most widely used VPN protocol.
Yeah, right.
VPN. What we can say? The most widely used VPN, right? Which provide a strong security, like your encryption, authentication. It works at layer 3, It is scalable, provide scalability, support side-to-side VPN, support remote access VPN, DMVPN, everywhere you can run it. Okay, so you will be using IPsec VPN in these scenarios. See, side-to-side VPN in case of side-to-side means connecting branch offices securely over the internet. We can use it in remote access VPN. Here also it can secure my tunnel. In the remote access VPN also it can encrypt the data. It allows employee to access office network securely from anywhere, right? In the cloud VPN also you can use it. Cloud VPN means connect on premise data center, on-premise data center to the cloud, like your AWS, Azure, or GCP. Everywhere, see, we are using IPsec, right? And definition can be, yes, it is group of protocol, or we can say it is a framework for securing network communication at network layer. What can be the definition? It is a group of protocol protocols. You have seen so many protocols, right? Like in phase 1 and phase 2. In phase 1, ISACAM. In phase 2, ESP, right? So it is group of protocols or framework for securing network communication at network layer or layer 3. Layer 3 or network layer. Clear? Right? It provides features like encryption, authentication, and integrity. Right? And guys, IPsec operates in 2 modes. IPsec provide these features. IPsec operates in 2 modes. Bro, put
Tunnel mode
yourself
and
on mute.
transport.
Getting noise. In 2 mode. May I know the name of both mode?
Tunnel mode and transport mode.
Yes, very good. And what is the meaning of mode? Means IPsec operates in 2 mode means depending on how much of the packet is encrypted. You want to encrypt the entire data or you just want to encrypt the payload. On the basis of that, we have 2 mode. First one is tunnel mode and second one is transport mode. Right? Tunnel mode is going to encrypt everything. Tunnel mode is going to encrypt, here we can say encrypt the entire IP packets. And after that, if it will encrypt everything, then how internet routers are going to forward the traffic, right? So what it will do, it is going to add new IP header. What it will do, it will add the new IP header. It will encrypt everything and after that it is going to add new IP header. For an example, if I will give you one example, let's say before IPsec user have generated one data, before IPsec tunnel, before IPsec user have generated one data. In the data there are some information like original IP header plus data. Original IP header and data. What it will do, IPsec is going to consider everything as a data after IPsec. If you have configured the tunnel mode, if your IPsec is operating in tunnel mode, then it will consider everything as a data, right? So we will have encrypted data here, encrypted data, which includes original IP header as well as my data, and it is going to add the new IP header here. New IP header, right? So ISP routers, internet routers are going to use this IP header to forward the traffic, right? The original even IP is hide it, right? Even the IP header, your IP header is hidden, guys. Here you can see. And if I will talk about the transparent mode, so transparent mode is only going to encrypt the payload, right? For an example, again, user have generated the data, right? And there is original IP header plus data. So what it will do? Transparent mode. This is before IPsec. This is before IPsec, and here I will talk about after IPsec. In which mode? In transparent, in transport mode, right? So original IP packet is going to be seen, and it is going to encrypt the data plus encrypted data. Encrypted data. We will have like this. Clear? The both mode is clear, guys. IPsec works in two mode, and mode means depending on how much data is going to be encrypted. On the basis of that, we have two modes: tunnel mode and transport mode. Tunnel mode is going to encrypt everything, entire IP packet, and it will add the new IP header, and transparent mode is going to just encrypt the payload. Clear? After that, next thing. What happened, guys? Am I audible? Not audible?
Yes, sir. Yes, sir.
Yes. Now we can say IPsec uses two main protocols. May I know the name of these two protocols? First one is authentication.
ESP.
Yes.
Header.
Authentication header.
Header.
And the second one is
ESP.
ESP.
Encapsulating
ESP. ESP stands for
Encapsulation.
Encapsulation security
Security
payload.
payload.
encapsulating security
Payload.
payload. Payload. Right? What is the difference? See, the HA authentication header only provide authentication, not encryption, and ESP provide authentication as well as encryption. That's why we are always using what? ESP. Getting my point? HA protocol only provide authentication. It will only verify the user, not encryption. Your data will travel in plain text only. Okay, so if your requirement is, let's say your priority is only and only data integrity and authentication, you can go with EH. But if your priority is encryption, secure tunnel, then ESP, and mostly we are using ESP only. ESP is commonly used protocol in IPsec VPN. Right? ESP is better because it provides both. Yes or no? Yes. As it is providing both encryption and authentication, we are using it. Now, what happened? Okay, no problem. Now, how IPsec works? How IPsec works? After that, I will show you the configuration. So, IPsec, as I already told you, IPsec works in two phases. Phase 1, it works in two phases. Phase 1,
Yes.
and phase 2. What is the purpose of phase 1? Now you tell me.
Sir, it's creating the key
To create the
Key exchange.
right?
See, both the
Questions.
phase is going to establish secure VPN, right? VPN tunnel, you can say. Both the phases are going to establish a secure VPN tunnel in two phases, phase 1 and phase 2, by using which protocol? IPsec establish a VPN tunnel, or you can say secure VPN tunnel, in two phases by using a protocol called
ISAC
IKE, Internet Key
key
Exchange,
exchange.
right? And the purpose of phase 1 is nothing but the building a secure channel to exchange the key. Building a secure channel to exchange the session key. To exchange the session key. And which algorithm or protocol is going to help me here?
ISAC
Diffie-Hellman. Diffie-Hellman will help you too. See, the Diffie-Hellman is only and only responsible for generating the key. That's it. After a specific interval of time, generating a key. And through this secure channel, will exchange that key. So it creates a secure authenticated tunnel between VPN peer by using pre-shared key, which you have already seen. Yes? Bro, put yourself on mute if you are not speaking. Please, I am requesting. Now
Okay.
guys, in phase 1,
Later, I have meeting with somebody by 6:30. But
wait, put yourself on mute now, please. Now, phase 1 can,
by
phase
6:30.
1, who's this here? Arun, are you there?
Okay. If I finish the meeting by 6:30, then I'll come around. If I couldn't finish in time, then tomorrow morning, after morning mass, if you go to morning mass. Okay, sir.
Phase 1 can run in again two modes. First one is main mode, and second one is aggressive mode. Aggressive mode. Main mode is more secure but slower than aggressive mode. Aggressive mode is fast but less secure. So according to your requirement, you can configure any mode. In phase 2, or sometimes we are saying IKE phase 2 also, are going to negotiate the all algorithms, like the once we will have the phase 1, you know, both the routers are going to negotiate the algorithms like encryption algorithms, hashing algorithms. If everything is matching, both have already session key, so we'll use that session key to encrypt. Then it will establish IPsec Security Association, right? We can verify this only after configuration. What we can verify? IPsec Security Association, right? So there are two types of security association, or we can say SA in short term: ISACamp Security Association and IPsec Security Association. ISACamp SA is going to establish in which state, in which phase? In phase 1. And IPsec SA will be established in phase 2, right? And after that your all packet is going to be encrypted, all the user data is going to be encrypted. If I will talk about, guys, encryption algorithms, so what are the encryption algorithms available?
AH dias.
DS
DS, 3DS, AES.
for the encryption.
3DS, AES.
Encryption we can use
SH,
DS, we can use 3DS. 3DS is more secure than DS, and after that ES. ES is more secure than 3DS. For the hashing,
SHA, SHA,
for the hashing I can have MD5
NSH.
and
Before SHA.
SA, right? So even you can check the MD5 or SA algorithm on Google. You can search it, you can put some data there, it will calculate one hash value for you. It will create one hash value for you. So IPsec Security Association build a secure channel for phase 1 for exchanging the key, session key, and IPsec Security Association encrypt actual data packet by using ESP protocol. Now can we see the configuration, guys? And while configuration we can discuss if you will not understand anything. I am going to configure GRE over IPsec, IPsec over GRE, username. Okay, my devices are on. See, first I am going to access internet router, and on the internet router I will only and only configure IP addresses, nothing else. On the internet router I am going to configure IP addresses only. Interface config T, host name I am saying internet, and then interface F0/0, say no shutdown, and IP address 1.1.2 1.1.2 exit interface F1/0, again no shut, and IP address 2.2.2.1.255.2.2.2 no shut is already there. So IP interface brief, you can verify it, and let me save the configuration and let me close the console of internet router, because now we are not going to configure anything on internet router. And let me access R1 and R2. Yes. Now let's begin the configuration from order number 1. On order number 1, I'm going to configure IP addresses. I will create one loopback here for the LAN. Host name R1, interface F0/0, say no shut, and IP address 1.1.1.1.255.255.255.0. Then interface F loopback 1, and IP address 192.168.1.1 exit, then one IP route, default route towards internet 0.0.0 0.0.0 F0/0, and next hop IP 1.1.2. Now let me take you to router number 2 and let me do the same configuration there also. Host name R2, interface F0/0, no such, and IP address is going to be 2.2.2.1, 255.255.255.0. Interface loopback 1, IP address 192.168.1. 255.255.255.0, and then IP route 0.0.0, 0.0.0, exit interface F0/0, next of IP 2.2.2. Now tell me, can 1.1.1 ping 2.2.1 or not? If I will ping 2.2.2.1 from router 1 with source 1.1.1, will it work? Ping will work. Will ping work?
No.
Please type in the chat yes or no.
No.
Ping will work because both routers have default route, right? But two private side cannot communicate, as you know. Public to public reachability is there, right? Both public IP addresses are reachable, right? For public reachability, internet is responsible. That is their concern. But for communication between two private sites, I have to configure here tunnel, GRE tunnel, right? Let me create one tunnel here. Interface tunnel 1, GRE tunnel, and then I am saying tunnel source is fast Ethernet 0/0, and I am saying tunnel destination because this is point to point tunnel, side to side. That's why I am defining the tunnel destination. And then IP address. Let's say on the tunnel I am running IP 10.1.1.1, 255.255.255.0. Go to router number 2 and say interface tunnel 1, tunnel source fast Ethernet 0/0, and tunnel destination 1.1.1.1, and IP address 10.1.1.2, 255.255.255.0. Now you can see, so IP interface brief. I have one tunnel interface tunnel 1 with this IP, and their status is up, their line protocol is also up. On router number 1 also, so IP interface brief. Tunnel interface is there. This is the IP address, status, line protocol, right? Now the both tunnels are reachable with each other. Ping 10.1.1.2 and source 10.1.1.1. See, ping is working. You know how router is now forwarding the traffic. When I am going to ping this IP address 10.1.1.2, router will compare destination with routing table, right? It is going to open so IP route 10.1.1.2, and it will find what? Exit interface is nothing but the tunnel interface. And whenever exit interface is tunnel interface, it is going to perform encapsulation. It is perform encapsulation. Like when I am pinging 10.2 from 10.1, source IP address is going to be, there is ICMP data, actual data payload. After that, source IP is there 10.1.1.1, and destination IP is there, which is what? 10.1.1.2. And router is going to compare destination IP address, source IP 1 and destination IP 2. Router 1 is going to compare destination IP 10.2 with routing table, and it will find exit interface is tunnel interface. So if exit interface is tunnel interface, it will perform encapsulation. It is going to add one new IP header. New IP header. And what will be the information in new IP header, guys? Source IP will be tunnel source, and destination IP will be what? Tunnel destination, right? So tunnel source, you know what is tunnel source here? 1.1.1, and tunnel destination is what? 2.2.2.1. So when internet router is going to receive this traffic, internet router will open this IP header, and see in the outer IP header both the addresses are public, right? So internet router will have route, and it will route the traffic. When it will reach to router 2, again router 2 will open this header first. It is going to check the protocol field. In the protocol field there will be protocol number of GRE. Here we will have GRE header. GRE header. Like this. Right? Every time, whenever exit interface is tunnel interface, it will perform GRE encapsulation. GRE encapsulation. If you want to see, I can capture any link. Let's say I'm capturing the internet F0/0 link. T192.101.17.22 root if. Let me try now. Now you can see capturing started. Right, here is my capturing data. Now if I am going to again ping from source 10.1 to destination 10.2, source 10. Ping 10.2 from source 10.1, and here you can see the ICMP packet. In the IP packet, guys, source IP address is see 10.1, destination IP 10.2, but in outer header, in the outer IP header, there are not two IP header. One is outer, one is inner, right? This is my actual data, then this is my IP like network layer header, then GRE header is there. Between L3 and L2, GRE added this layer, this header, IP header, right? And in the outer IP header, source IP 1.1.1, destination IP 2.2.2.1. If you are going to open it, you can see the encapsulation protocol. Where is protocol? Protocol is what? Encapsulation. GRE. Generic routing encapsulation, protocol number 47. If you are going to open the normal packet, protocol value will be ICMP protocol number, right? Here you can see. So on router number 2, when router 2 will receive the traffic, router 2 is first going to verify layer 2 information. After that, it is going to check this outer IP header. In the outer IP header, destination IP address is 2.2.2.1. This is the IP address of router 2. Router is going to check, like for router 2, it is now routed packet. It is going to check protocol value. In the protocol value, it will see the protocol number is 47. That means GRE protocol is running. It is going to hand over the traffic to whom? GRE. And in the GRE header, you can see type. Protocol type is IPv4. It will hand over to IPv4. Only router 2, like the router who is using this IP 2.2.2.1 will open inner IP header. And after that, it will say, okay, destination is this one. Right, so now we have tunnel. Through this tunnel, we can make reachability between these two sites also. I can say, I can do one thing, I can enable any routing protocol. Let's say router OSPF 1, router ID 1.1.1.1, and network 10.1.1.0, wildcard mask 0.0.255, area 0. This command will enable OSPF on which interface? Network 192.168.1.0. Wildcard mask 0.0.255, area 0. Right? So this command will enable OSPF on my loopback interface, and this command will enable OSPF on tunnel interface. So IP OSPF interface brief, you can see the OSPF is enabled on both interfaces. Similar way on router number 2 also I can configure the OSPF protocol. This is GRE, router OSPF 1, router ID 2.2.2.2, network 10.1.1.0, wildcard mask 0.0.255, area 0, and network 192.168.2.0, wildcard mask 0.0.255, area 0. Now you can see here we have OSPF neighborship over the tunnel. So IP OSPF neighbor, and through OSPF side 2 is learning side 1 prefix. So IP dot OSPF you can see 192.168.1.1, and again exit interface is what? Tunnel interface. So to forward traffic in this network, it is going to perform encapsulation. It will add the header on daughter number 1 also. So IP route OSPF, you can see site 2 prefix is coming. Now if I am going to ping 192.168.2.1 from the source, 192.168.1.1, will ping work? Yes, ping will work. And source IP 192.168.1.1, destination IP 1.2, and GRE is going to perform encapsulation. You can see here in the outer header, again we have same tunnel source, tunnel destination. Source IP in the outer header is tunnel source, destination IP is tunnel destination. Right, this is reply message. But you can see my data is not encrypted, right? Everything is in plain text. Anyone can read it. So now we can configure IPsec here to secure my data to perform encryption, authentication, and integrity. We can configure now IPsec. Let me configure IPsec. First of all, I am going to configure phase 1 here. Phase 1. In phase 1, I will configure IPsec protocol. So say crypto, IPsec, and then policy, right? Then policy number. Let's say 10. This is similar like your OSPF process ID, sequence number, like that, right? So this command is going to enable IPsec policy number 10, and here I will define the encryption protocol. Which protocol it should use for encryption? Tell me which protocol you want to use. 3DS is there, AES is there, and DS is there.
AES.
AES, right? AES is more secure, and 256. Then we can define the hashing algorithm. SA 256. Then I can define the authentication and see if I will put question mark over here for the authentication. I have pre-seared RSA encryption and RSA sign for the certificate. So I am going to use pre-seared for authentication. Means manually we will configure the key. For phase 1 we will configure the manually key, and then we can define the lifetime. After how long time it should generate the key dynamically. Let's say 1000 seconds. And then to create dynamic key, we have to configure group number. With the help of group number only, Diffie-Hellman is going to generate the key. So if I will put question mark, you can see these are the groups. Diffie-Hellman group number. I am going to say, for an example, 14. That's it. Now do show history. I can see how many things I have configured here. Crypto IPsec policy 10, encryption algorithm, hashing algorithm, authentication method, lifetime, and group. I am going to copy this command and will put same command on daughter number 2 also. Right? It is important for authentication. Key should be same. Now we will configure the key, same key. Now we have defined the algorithms for secure channels for phase 1, right? And now I can configure the key here, right? Exit from here, pre-seared key. I can say crypto IPsec key. Let's say key is Cisco. Cisco is my key, and then address for whom? For 2.2.2.1. Right, so it is going to share this key to 2.2. Like it will authenticate 2.2.2.1 with key, and they should have also same key. So I will add this command on daughter number 2 also. Crypto IPsec key, and key is going to be Cisco, and address 1.1.1.1. If I am defining the address, means it will form secure channel with this address only. If you will not define the address, it is going to establish secure channel phase 1 IPsec secure tunnel with any device. So better to configure the peer address as well. This is nothing but the peer address. Is my phase 1 configuration done? Yes, your phase 1 configuration is done. There are some verification command, like you can use show crypto ISACAM policy. It will show you the ISACAM policy configuration. So you can see we have one policy number 10, and you can see the encryption algorithm, what encryption algorithm I am using, advanced encryption standard, and the size 256 bits. More size means more secure. Hashing algorithm, secure hash standard 2. Authentication mode, pre-shared key, and group number live. Right? You can verify the key also. So crypto ISACAM, and then you can say key here, I think. Key, yeah, you can see key for this peer is Cisco. Key for this peer is Cisco. If I have multiple key, I can configure multiple key for multiple peers. Right? And so crypto ISACAM SA. Here we can verify the security association. We are not able to see anything. Do ping 2.2.2.1 source 1.1.1. Here I am expecting the output. Okay. Now let's configure phase 2 here. For phase 2, instead of ISACAM, you will use IPsec protocol crypto, and all the commands are starting from crypto only, because I am configuring cryptography. All the commands for cryptography will start from crypto only, right? These are the basic security term. Crypto IPsec, and then we can say transform set, right? Name of your transform set. Let's say PM is name of my transform set, and here we can define the ESP protocol like encryption and hashing. ESP should use AES algorithm. ESP should use for encryption. ESP should use, let's say, MD5 for hashing, like this, right? And then mode, how many modes are there? Tunnel and transport, right? If you will put question mark, you can see transport mode and tunnel mode, both are there. So I'm saying, let's say transport. Phase 2 configuration is also done. Do show history. Phase 2 configuration is done. Let me copy it. In phase 2 also you can see I have only defined the encryption hashing algorithm, and I have defined the mode, tunnel mode, and I am going to run this command on router 2 also. Now we need to finally apply it on the interface. On which interface I will apply it, guys? On the which interface I will apply it? On the tunnel interface. But issue is we cannot apply it directly on the interface. We have to create one profile to apply it on the interface. So let me create one profile, crypto IPsec profile, and name of profile is, let's say, PM, and here I am saying calling set transform set PM. I am calling to my transform set, same transform set, and exit. And now we can apply it on the interface tunnel 1 and tunnel protection IPsec profile. Which profile? Name of profile is PM only. PM. Now you can see my tunnel goes down. My tunnel goes down because we need to apply it on router number 2 also. Now if I will ping 10.1.1.2, ping is not working now. See, if you will check show IP interface brief, it's showing up here. OSPF membership is also expired. So let me apply it on router number 2 also. Here also I need to create one profile. Crypto IPsec profile, name is PM. Let's call to transform set PM and go to tunnel, interface tunnel 1 and tunnel protection IPsec profile, and let me call to my profile PM. Exit. And now again you can see my tunnel is up. OSP of neighborship is again up. So crypto ISACamp SA. Now you can see the SA. The state is active. Similarly, I can verify the IPsec SA also. So IPsec, so crypto IPsec SA. You can see. Right, and now I am going to ping 192.168.2.1 and source 192.168.1.1, and let me show you the capturing here. Capturing and ping. Now you can see your packet look like this. IP header is visible. Why? Because we have set which mode of tunnel? Transport. If you want to encrypt everything, you can use tunnel mode. Now you can see if I am going to open it, you can see how it's look like. Here is encapsulating security payload. Right, so this is your actual data. ISP have only access of this IP header for the forwarding. Clear, guys? Yeah, Satyam, Sayan. Tunnel. So there are so many things we cannot cover it like in 2 hours, 2.5 hours. I am speaking from last 2.5 hours, but still I have not covered the everything. But I try to cover the all important things here. Similarly, you can get the IPsec tunnel also, right? The pure IPsec. This is IPsec over GRE. Over GRE, we have created the IPsec. You can have the direct IPsec also. Now tell me, guys, how was the webinar? Any suggestion for me? Please type in the
Sir,
chat.
if you provide the note, it will be better for us.
Huh? What?
If you are providing the notes, it will be very helpful us.
Where is the note? I have not used any notes, even I don't have notes.
Sir, without theory, how?
I don't
Without
have notes,
theory,
bro.
how we will study this one?
You can
Have
pick the
you
book.
recorded this session? Have you recorded this session?
Book.
Hello?
You can create your own note. Yeah, recording is there.
Okay, can you put it in YouTube, sir? So we have to watch after.
Lakshman, thank you so much. Suman, it's excellent. Thank you, bro. Okay, guys. That's all for today. In
Yeah, thank
future,
you for good
definitely we'll
sessions.
have more webinar on the popular topic. If you have any specific topic, you can also let us know on WhatsApp or in the YouTube videos. You can put the topic name in the comment section, right? And we'll try to schedule the webinar accordingly in future.
Thank you.
Sir, this WhatsApp group is gonna be temporary or is gonna be permanent?
What? The tunnel is going to be
The WhatsApp
permanent
group.
after 1000 second it will be resetting the key. It will be generating new key. Now it will be not using
No.
same
I'm
key.
talking. I'm talking about the WhatsApp group.
WhatsApp group.
Yeah.
Yeah, I think WhatsApp group is going to be permanent. It will be same, right? Maybe when we launch the next webinar, we'll rename the group. We'll change the name of group,
Oh, okay.
but group will be there. You can stay there.
Yeah, but I had a stupid question that I wanted to ask you. I don't really understand the difference in between layer 2 MPLS and layer 3 MPLS. I don't know.
Layer 2 and layer 3. Difference between layer 2 MPLS and layer 3 MPLS.
Yes, sir.
Both are VPN. What is VPN? Encapsulating. So if we are encapsulating the traffic at layer 2, that is called layer 2 VPN. If we are encapsulating the traffic at layer 3, that is called layer 3 VPN. VPN means nothing. Now the meaning of VPN is encapsulation.
No. Sorry, that was not the question. I was talking about layer 2 MPLS and layer 3 MPLS. I'm sorry.
Yeah. I am also talking about L2 and L3 MPLS VPN.
Okay.
Please share YouTube link or channel. YouTube is PM Networking YouTube. Let me show you here my channel. YouTube. Here is my YouTube channel. Even on YouTube also the today's class is available. Maybe now it's not showing. This is a different channel, not. This is my channel. Here it is. You can see the video of today class is also available here. IPsec VPN. Right, and many other courses are there. Like if anyone want to learn from the scratch the networking, right? So many courses are there. CCNA, CCNP, Palo Alto Firewall, SD-WAN, right? WAN is technology. The scenarios, real-time scenarios, Python, right? Then small courses are there for OSPF, BGP, MPLS. Complete MPLS course is here. Like if anyone want to learn L2 and L3 VPN in details, MP BGP in detail, you can go with this playlist. So these are course created by me on my YouTube channel. Very useful session, sir. Thank you, Praveen. Please share YouTube channel. Okay, this is my YouTube. Let me share with you. Copy, and I am putting it in the chat here. Yeah, here is the link. Thanks. I am from Bangladesh. Welcome. Very useful session. Thank you so much. Good night, sir. Good night. Excellent, wonderful lecture. So good session, sir. Awesome. It's excellent. Thank for the webinar. Thank you so much, guys, for the appreciation, everyone. I try to cover the important parts of IPsec, including VPN. We talked about many types of VPN, and detailed videos are already available on the channel for these topics. If any other topic is not clear to you, you can go with that topic. On YouTube, you can search topic and then you can put the PM networking tag there to find my video. Next time I will try to cover, try to schedule one webinar for pure IPsec configuration only, because today I could not cover the pure IPsec configuration, right? So as I told you, in pure IPsec you cannot configure the routing protocol. Then we'll see how we can make reachability between two sites, or we can see the IPsec implementation in DMVPN in case of multi-point. So those are the advanced topics, and definitely I am trying to cover, you know, multiple topics on the YouTube, and whenever I have time I am trying to schedule the webinar as well, and definitely in future I will be scheduling more webinars. That's all for today, guys. Thank you so much for joining. We'll connect again. Till then, stay safe. Bye bye. If you are watching me on the YouTube, please like the video. If you have not subscribed the channel, please subscribe it. If you are connected here in the Google Meet, that's great. Thank you, Praveen. Good night, guys. Good night.